UV visible spectroscopy basics. What is the difference between single beam, dual beam, and double beam optical design in UV visible spectrophotometers? Single beam spectrophotometers. The simplest spectrophotometers have a single beam optical design. In a single beam system, light from the monochromator passes through the sample and then into a single detector. By using fewer optical components, this allows for a reduction in the size and cost of these models. With a single beam system, the baseline must be measured separately from the sample. The measurement may be less accurate between the baseline and the sample being read if separate readings are taken, and some variation in the light intensity or the optical performance of the system occurs during this period. This inaccuracy is a problem for sample measurements that take a long time or where the reference can vary over time. For this reason, the user needs to alternate sample and reference measurements relatively frequently, as these do not have an automatic mechanism to eliminate the influence of photometric drift. Dual or split beam spectrophotometer. Dual beam or split beam instruments have a dedicated detector for samples and a reference detector housed within the instrument's optics. This offers the advantage of optical stability as occurs in double beam spectrophotometers. The only difference is that the user can only measure the reference and samples at the sample position, since the reference detector, being inside of the optical system of the instrument, is only used to correct photometric drift in real time. Double beam spectrophotometers. Similarly, spectrophotometers with a double beam optical design also have a sample detector and a reference detector. The difference is that the equipment has a dedicated physical position for the samples and another for the reference. That means that the user has access to the reference and can insert a cuvette with a reference solution. In this way, fluctuations in the light intensity of the lamp can be compensated for each measurement, thus neutralizing the effect of photometric drift in every read.